Well, hello again and welcome to the VK6CS amateur radio channel. Just thought I'd have another look at this old valve amp I've got from the a blast from the past from 1967, I think. Going into frustrated disc jockey mode there. Okay, now this parchment that was found in the tomb of Ramesses II is actually a complete circuit diagram of the amplifier. It's a Yaesu FLdx2000. Now on the net this circuit diagram is still available, but it's in two parts. So I've just noticed this one is complete. If I zoom out you can see I have the whole circuit diagram there in its entirety. So I think while I've got this in one piece I'll get a couple of copies of that, and I'll make an A3 copy that I can keep in my information folder for the amplifier, and I'll also save a soft copy so that I can print out the whole circuit in its entirety, which is a lot better than looking at one half and then looking at the other half, and some of the information was repeated. You know, it wasn't exactly a half and half, so it overlapped slightly. That's probably good thinking on somebody's part, but when you look at it you think, hang on, is that line or not? Okay, right. So what am I doing with it? Now, you may recall that the loading on the amplifier was maxed out on 40 meters. Now I think that into a dummy load, trying to get the thing matched properly into a dummy load, and it wouldn't load optimally. So I reckon that it's because the amplifier was designed to run 6 KD6s and it's fitted with 6 LF6s. So because the tubes are slightly different, or the valves are slightly different, the matching characteristics are going to be slightly different as well. So looking at the circuit diagram, okay, so here's the output tank circuit. There's the anode tune capacitor, or plate tune as the Americans call it. Here's the load capacitor. Now when you change the band switch around, when it gets to 40 meters, it switches in this 500 picofarad capacitor in parallel with the loading capacitor. Now I looked at the back of the band switch. See, what I was thinking of doing originally was just putting a couple of 47 picofarad capacitors across the loading capacitor. And I've got some nice ones from Russia that I think will do the job. There we go, 47 picofarad capacitors. I think these are rated at something like 3.5 kV, something like that. Yeah, 3.5 kV, 47 picofarad. See, I impressed you there with my reading of Russian, didn't I? I just recalled the advert, to be honest. But armed with some of these capacitors, I thought, well, I'll use two. I wanted 47 puff. I thought was ideal because, you know, 100 puff might be too big. But if I put two 47 puffs in there, I can strap them together. If it's too much, I can take one out. If I got a 100 puff capacitor, obviously I couldn't do that. I'd have to find another one and put it in series with it. So the idea was just put the capacitors directly across the loading capacitor and just add a bit of extra loading capacitance for each band. Then I thought, well, actually what I could do is, you know, at that point there on the band switch, I could put a couple of those capacitors. I tried it on 40 meters and the loading capacitor was not enough, so maybe, you know, one on 40 meters, on the 40 meter setting. So it's got a wiper that goes round, if you see what I mean, so that when it's on 80 meters it connects this, and the next one round it would, if I put a capacitor on that, it would connect that in parallel on 40 meters. So I thought, blow it, what I'll do is I'll stick with the original plan. I'll just put two capacitors directly across this. I'll try it on each band. Then if I need to worry about, you know, putting different capacitors on for each band, then I'll worry about it, because I'm a great believer in keeping things as simple as possible. So if all it needs is two of those across this, great. If it needs a bit more than that, like another two here, another one here, etc., then I'll cross that bridge when I come to it. Okay, let's just get that out of the way. Now here's the amplifier. I'll just take this camera This is amateur radio, don't have to be Discovery Channel quality of videoing, doesn't have to be. There we go, so it's the FLdx2000, the amplifier. I've taken the valves out. Looking at that hole down the bottom where the fan is, see that's really rough around the edges? That hole looks like it's been filed out. Now maybe someone's drilled it out or filed it out to put a bigger fan in there. I don't know, I'll have to have a look at some pictures, see if I can find a picture of the original thing to see if it was actually blown from the underneath. Or there is a square hole in the side that somebody's cut. I don't know if you can see that, there's the edge of it there. There's an aluminium, this is an aluminium plate, and that's the steel side as was, but that edge is pretty rough. Anyway, down in there are the two capacitors that I mounted yesterday. The two 47 picofarad capacitors in parallel. They've got solder tags on the top. There's a bit of 1mm building wire there. I'm just going to solder that there and solder it onto here so it's in parallel with the loading capacitor. And if I continue to swing the camera around, you can see the band switch there. There's the band switch, and that's the capacitor there, 500 puff, that's switched in circuit on 80 metres. So that's what I'm doing with the amplifier at the moment. Now if I had my little capacitance meter with me, it's over the other side of the room at the moment, so I won't put the camera down and go and get it, that would be just too excruciating, but I'll get my capacity meter, and with it selected to another band, so this capacitor is just sitting there on its own on the switch, I'll measure that capacitance, and I'll just make sure that that's still around 500 picofarads, that it's not going to open circuit or it's not leaky. So that's just something I'll do while the amplifier is in bits. So there we go, old school amplifier from 1967. As I say, the valves or the tubes are removed. There's the four sockets. There's the anode choke. It's just my bit of building wire going across here because I've just I just had a burst of enthusiasm for doing a video when I was sort of halfway through doing it. So there we go. There's the power supply. I might change those HT capacitors depending on the performance of the amp. And of course, because this amp is of a vintage where it would have been driven by a solid state radio, there's no tuning on the input. The input comes straight in, goes through a little low pass filter straight onto the cathode, so I might make some kind of input arrangement that will present the drive radio with a 50 ohm impedance. What I actually thought would work quite well would be a 50 watt 1.5 dB attenuator, because that would present 50 ohms to the radio. Not worry about the impedance too much on the other side, but it's probably, if I could get hold of such a thing, because we use the 10, 20 dB 100 watt attenuators at work, and I think I've actually done a video showing those. They're quite sizable. I wouldn't be able to fit one of those in here, but I was thinking along those lines because, as I said previously, I'm a great believer in keeping things as simple as possible. And if I can get away with doing something like that rather than having some kind of tuned input, then that's the way I'll go. I don't really want. I think it's a nice looking amplifier. I don't really want to drill any holes in it, even though it's been a bit butchered. The metalwork's been a bit butchered in here. I'm still not overly keen on cutting holes in the front panel. All right. Well, as always, I hope you found that interesting. And I'll catch you next time.